Telescopes generally come into two different flavors. You have really powerful big telescopes, but those telescopes see a tiny part of the sky. Or telescopes are smaller, and so they lack that power, but they can see big parts of the sky. WFIRST is the best of both worlds.
WFIRST is the Wide Field Infrared Survey Telescope. What I think of WFIRST is doing is building on what were the two great successes astronomically of the 1990s and the last decade. That is the Sloan Digital Sky Survey and the Hubble Space Telescope.
WFIRST is a NASA observatory that has the top ranking of the National Academy of Sciences to launch in the 2020s. It has the same image precision and power as the Hubble Space Telescope, but with 100 times the area of sky that it views.
Looking at a large fraction of the sky allows you to get a more complete accounting. For example, the stars in the Large Magellanic Cloud, which is the nearest galaxy to us, or the stars in the galactic bulge. So you can do a much more complete accounting in a much shorter amount of time. The particular thing I'm interested in using WFIRST for is to actually do a statistical census of planetary systems in our galaxy. And what we're looking for is gravitational microlensing events. These are cases when another star passes in front of our line of sight to a background star, and it makes that background star get a little bit brighter due to the gravity of that foreground star. And that allows us to find planets.
What WFIRST will do is it will have what we call a coronagraph. A coronagraph lets us image and characterize really dim planets next to very bright stars.
No matter how good a telescope that you build, it's always going to have some residual errors. It's going to be the first time that we're going to fly an instrument that contains these high format deformable mirrors that are going to let us correct for errors in the telescope. That's never been done in space before.
WFIRST will allow us to potentially make groundbreaking discoveries, finding out what dark energy is. So this will tell us if dark energy is an unknown form of energy or if it's a modification of general relativity.
Single WFIRST images will contain over 1 million galaxies, and we can't categorize and catalog those galaxies ourselves. Citizen science allows interested people in the general public to solve scientific problems. And so one of the things that I'm really excited about is enabling this bridge where the general public can get involved in doing actual science.
For me, it's a really exciting opportunity to play a significant role in a mission that I think will be one of the most powerful telescopes that we have in the 2020s and will be some of the most important things our country does in space in that time frame.